Okay, so question 23 says that the drawing shows two planes each about to drop an empty fuel tank. At the moment of release, each plane has the same speed of 135 meters per second, and each tank is at the same height of 2 kilometers above the ground. Although the speeds are the same, the velocities are different at the instant of release, because one plane is flying at an angle of 15 degrees above the horizontal, and the other is flying at an angle 15 degrees below the horizontal. Find the magnitude and direction of the velocity with which the fuel tank hits the ground if it is from plane A and plane B. In each part, give the directional angles with respect to the horizontal. Okay, so we start off by writing our x components. And we know that the initial velocity in the x, using our cosine function, is 130.3 meters per second. Final velocity is going to be the same. Our acceleration is always 0. And we don't know our displacement or our time. For our y components, using our sine function, we find that the initial velocity in the y is 34.94 meters per second. We don't know what the final velocity is, and we know the acceleration is negative 9.81 meters per second squared. The displacement is 2 kilometers, which is equal to 2,000 meters. And our time, we don't know. So, in order to solve for the final velocity of the of the fuel tank, in the y we have to use the equation that the final velocity squared is equal to initial velocity squared plus 2 times our acceleration times our x. So we start off by solving for our y, and we find that the final velocity in the y is equal to negative 201.15 meters per second. So in order to solve for the final velocity of the tank if it's dropped from plane A, we have to use the Pythagorean theorem again. So we get that the final velocity is equal to the square root of our final velocity in the x squared plus our final velocity in the y squared. And we get that our final velocity is equal to 239.72 meters per second. In order to find our angle, we have to use the inverse tan function. And we plug in our y value and our x value to give us an angle of 57.1 degrees. So that's for part A. We have the final velocity and the direction. Now for part B, the only thing that's really changing in part B is the angle. The angle is now going to be negative 15 degrees because it's below the horizontal. However, we're still going to get the same initial velocity in the x, and we're still going to get the same initial velocity in the y. And all other components are going to be the same. Therefore, once we solve for our final velocity for part B, we find that the final velocity is the same as the final velocity in part A. And therefore our angle should be the same. So for part A and for part B, they both have the same angle and they both have the same magnitude.